Hey everyone, my name is Brandon Gracely. I'm a high school math teacher. We are going to learn about the factor theorem for polynomials, and to do this you're already going to need to know about the remainder theorem, so back up and take a look at that if you haven't already. So we're going to find out what happens when we divide p of x, that's x cubed minus 7x plus 6, by the polynomial or the binomial x minus 2. So first, let's check out the remainder theorem. It says that the remainder will be the same value that I get when I evaluate p at positive 2. Let's see, so that's going to be 2 cubed minus 7 times 2 plus 6, that's 8 minus 14 plus 6 equals 0. So that means that the division will have a remainder 0. So let's go ahead and divide. So I have x cubed. Now I don't have a squared term, a quadratic term, so I'm going to have to add one in there. Okay, so let's start with x squared. That gives us x cubed minus 2x squared. Now I have 2x squared divided by x is 2x. We have a minus 3. Oh, I'm sorry. And there's our 0 remainder as expected. Now our statement here, what we know about this then is that x cubed minus 7x plus 6 is x minus 2 times x squared plus 2x minus 3, and there's no plus anything at the end. There's no remainder. So the factor theorem is excuse me, is this statement here: x minus b is a factor of some polynomial p of x, and we use this phrase: if and only if p at b, that b there, equals 0. Now this phrase, if and only if, this comes up quite often in math. It means that these two statements are equivalent. X minus b is a factor of polynomial p of x is the same as, or happens exactly at the same time when p at b equals 0. So if this happens, then the first statement is true. If the first statement happens, then the second statement is true. They are equivalent in that they happen at the same time. Now this phrase is so common that we will sometimes even write it in an unusual way. It's the word if, but written with two f's. If and only if. Now, for this particular polynomial, this x minus 2 might have seemed like a lucky guess. Like, how many different possibilities are there? There aren't that many things that are going to work out. X minus 2 works, and if you could factor this, maybe you would find some other things that would work, but like, what about x minus 5, or what about x plus 7, or what about x plus a half? Can those work? And so to know which factors to consider, we're going to need another strategy. So let's take a look at an example. Suppose x minus some unknown b is a factor of this polynomial. P of x is x cubed plus 2x squared minus 13x plus 10. So if we had that factor, we're going to try to work on what this could be, then this statement must be true. If I were to substitute b in here, p at b, I would get this, b cubed plus 2 times b squared minus 13b plus 10 would be equal to 0. And that just comes from the factor theorem, remainder theorem. So let's just reorganize this just a little bit. I'm going to leave all of these b terms, and I'm going to subtract 10 from both sides. Now, check it out. I'm going to factor on this side only. See how each of those has a b in it? So let's do some common factoring. I'll be left with, oh, sorry, that was a b cubed, so now I have a b squared plus 2b minus 13 is negative 10. So let's take a look at what this means then. Some number b times this polynomial, which has b in it, when you multiply those, you get negative 10. So if we're going to get a nice factor like this, then b has to divide nicely into negative 10. And this other expression also has to divide nicely into negative 10. So if this is a factor, then we have that b and also this quadratic here, b squared plus 2b minus 13, are both factors of negative 10. Now, what are those factors? There are a lot of them. Possible factors to consider? Well, there's 1 and negative 1, 2, negative 2, 5, negative 5, 10, and negative 10. Now, we don't need to list things like 7. That doesn't divide evenly into 10. So if we have this nice x minus b factor, we're going to get these possibilities for what b could be. So b has to be a factor of negative 10, so it's got to be in this list. I don't need to try all possible numbers, only this list. Now this is a list of 8, which isn't super fun, but it's at least a limited list. It's not an infinite list. So this leads us to a formal theorem. So let's write this down. It's called the integral zero theorem. Integral zero theorem. It's a little bit long, and I'm going to try to write it in a concise way for you. So basically what we were just talking about becomes the integral zero theorem in general. So we're going to write it like this. If x minus b is a factor of polynomial p of x with integer coefficients and leading coefficient 1. So that's all of talking about the polynomial. So if we have x minus b as a factor and the polynomial has all integers and it starts with a 1, so like x cubed, for example, 1x cubed, then b is a factor of the constant term of p of x. So this is what we just talked about. This is what helps you to decide what kinds of factors are possible, what should I think about trying to divide by, or what should I think about trying to find as a factor using the remainder theorem and the factor theorem. So let's look at an example of how this actually works out again then. So what are the possible integer roots or zeros of p of x, and this is the p of x that we're going to write down. P of x equals x cubed plus 6x squared plus 11x plus 6. And I want to point out, none of this stuff at the beginning here matters. What matters is the 6 and the fact that we have a 1x cubed, a leading coefficient of 1. And everything's an integer, but other than that, this could be like a 74 and this could be negative 100. It doesn't matter. The 6 at the end is the thing that really matters. So our solution, possible factors are plus or minus 1. So I've listed plus 1 and minus 1 together here. Plus or minus 1. Plus or minus, that's supposed to be a 2. Plus or minus 3. And plus or minus 6, because those are all factors of 6. That's the thing that really matters here. So we look there. So now you might be wondering, well, what happens if we don't have a polynomial with integer coefficients, or we don't have a 1 here? What if this was 2x cubed or something like that? Well, if that happens, we end up with factors like, if this was a 2 here, we could end up with a 2x minus 7 type factor. And so let's take a look at that now. So this is called the rational zero theorem. And you're going to see why at the end, remembering that a rational number is like a number you can write as a fraction. So yes, there will be fractions here. So once again, we have if p of x is a polynomial function with integer coefficients, and we have x equals b over a is a 0 of that polynomial function. And remember that when we learned about this with the factor theorem, a and b are integers and a can't be 0, so you're not dividing by 0. Then a couple of things here, 3 things. B is a factor of the constant term of p of x. So that's just like the integral zero theorem. But here's the next part. A is a factor of the leading coefficient. So a goes into the beginning, b goes into the end. And finally, we can write this in as a factor instead of just as a 0. Ax minus b is a factor of p of x. So it's another way to say this. These are interchangeable as well, just like in the last one. If ax minus b is a factor of p of x, then you're going to have these other ramifications too. So let's write an example here to show exactly how this works. Let's say p of x equals 4x squared minus 11x plus 15. So if we had something like ax minus b is a factor, then what do we know? A is a factor of 4, or another way to say that is 4 is divisible by a, or another way to say that is a is a factor of 4. And also we know that 15 is divisible by b. And that's the same as saying b is a factor of 15. So that means that a could be, or I was going to say is one of, but it only could be. It doesn't necessarily work out. A could be any one of these numbers. Well, could be plus or minus 1, could be plus or minus 2, plus or minus 4. Those are all the factors of 4. B could be plus or minus 1, then it's plus or minus 3, 5, or 15. So those are all of the possibilities. Now that's actually a lot because there are 6 different possibilities for A and 8 different possibilities for B, but I can help you out a little bit with that because we don't ever need to have a negative value for A. It can always be positive. So only consider positive values, because if we have that fraction style way of thinking about it, b divided by a, if you had like a negative on the top, you don't need to put a negative on the bottom. That'd be the same as them both being positive. So you only need to have one set of these, including all of its pluses or minuses. So this could be 1, 2, 4, and then all of the plus or minus versions can come down here. So those are all the possibilities that you would need to consider. So if the question were, what are all the possible factors to consider here, then you can say something like, well, I have to consider 1x plus 1, 1x minus 1, 1x plus 3, 1x minus 3, and so on through all of those, and then 2x minus 1, 2x plus 1, and so on and so on and so on. What you do here is once you find a number that works, or a pair of numbers that work, by testing it using the factor theorem, then you go ahead and divide out that factor and you'll be left with a smaller number with a smaller constant and fewer factors to consider.